Hi everyone, this is Todd from One Shot API. We have another on-chain N8N workflow for you today. We are revisiting the One Shot gas station that we submitted to Code NYC back in August. We've cleaned it up and streamlined it, made it easier to run. It's a great example of how you can run a backend for like a mini app or a regular D app in N8N and prototype and build fully featured on-chain applications really quickly. So this workflow has a smart contract component to it. The link to it is in the YouTube description. You can check it out. This is the periphery contract that you will be interacting with to make swaps with the Li.Fi DeFi protocol. It's basically a copy of the Li.Fi periphery permit proxy, except that it uses an EIP 3009 authorization rather than a permit signature. Because the gas station is intended to let users swap small amounts of stablecoin for native token, this one does some additional checks. It ensures that the receiver of the token after the swap is the person who authorized the transfer. And it also ensures that whatever swap is taking place is going to result in native token being received by the user. And lastly, it ensures that all of the value that the user authorizes is swapped into native token. So it does all of those checks for you, which are necessary if we're going to do like what this gateway is allowing, which is allow a third-party relayer to submit transactions on our behalf to the Li.Fi protocol. So check out that smart contract with the link, and we can go ahead and get started setting this up. If you click the link for the verified workflow in the YouTube description, at the top here, hit use for free and then copy the JSON to your clipboard. In your N8N account, hit create a new workflow, and then let's paste it. You'll see something like this. The only place we need to mess with configs is here in the payment token configs node. The way I like to set up on-chain workflows is to have a single code node where I put all of my configurations in, so there's one point where I can check all of those. And then if we look at the rest of this workflow, the next thing we do is we verify and validate the post body. Now the post body on this workflow is expecting 5 things that we are going to feed into the Li.Fi quote API. So it expects the from chain ID, the token address that the user is wanting to swap, the amount of that token the user wants to swap, the user's address, and then the destination chain. Where do I want to receive the native tokens on? This can be the same as the from chain, or it can be different. If Li.Fi cannot calculate a route to your desired destination chain, it will tell you in the 402 error code. But you need to put all of these quantities in the post body when you hit the webhook trigger defined by this workflow. And what's going to happen is this gets fed into this HTTP node, which is set up to hit the Li.Fi quote route. And I recommend that you create a Li.Fi integrator account. It will allow you to get a Li.Fi API key, which will increase your requests per minute that you can make against their quote route. You don't have to have this. I will turn this off for this video to keep it more simple. But if you get that API key, you can also set up your integrator name so that when you perform swaps for users or agents, you actually can set a fee amount. So in this case, when I'm running this, I'm actually collecting a small fee every time I relay a swap for a caller. And then lastly here, this code block is what validates and verifies our X payment header if we have one. And if we don't, it returns the estimate from Li.Fi back to the caller. And then if that X payment header does verify and validate, we proceed to simulating the call and then executing the call on the blockchain. So this is a great example of how you can build a fully featured DApp backend in N8N very quickly with very little code. And this would be great for serving as the backend to like a mini app that you want to run in like the base app or Farcaster or WorldCoin, whatever. Great way to build mini app backends. So let's get it set up to run. Click on the One Shot node, and if you don't have a credential yet, click on this top box, hit create a new credential. You need a client ID, secret, and business ID. To get that, log into OneShot API or create a free account. Come to the API Keys tab. Create a new key. So then your key and secret, go here. The business ID is in the top right-hand corner. Copy that. Put it in the business ID field. Hit save, and then you are authenticated. The next thing, let us go to the payment token configs. Here, the resource description. This is for x402. This tells the caller what the API route does. Your timeout, how long the authorization should be good for. 60 seconds is probably long enough. You can make it longer or shorter. Here, the gas station contract is the same for Base, Avalanche, and Arbitrum, but it is different for the Linnea network. So you can leave these addresses alone. You will need to get a gas station contract method ID. So that's the next thing that we're going to do in OneShot API. But to show you this here, the payment tokens array, this is where you configure which tokens you're willing to relay for. So I have USDC set up for Base, Avalanche, and Arbitrum. And then to show you something that's not just USDC, I have MetaMask USD on Linnea, and I have PayPal USD on Arbitrum. Now this max amount required field, I want to tell you about this one very quickly. Because you are charging, or because you can charge relaying fees, you might want to set a minimum amount that you are willing to relay for a user. So if you set 1,000, that's 1 cent. If I set it to 10,000, I'm saying the minimum amount that I'm willing to relay for this token is 10 cents. So that's what that's for. So let's go ahead and set up a contract method ID. Let's just do the base network to keep it simple, but it's the same procedure for the other 3 networks. So back in OneShot API, because we're relaying for users, we need a server wallet. So click on the Wallets tab, hit Create a new wallet, get a name and description, and then, again, this one we're doing base. Hit the base network, confirm, and then make sure you have a little bit of base ETH in that server wallet. A little bit will go a long way. Once you have that wallet, come to OneShot prompts and search for OneShot gas station. And then here's our version 2 templates. Let's click on the one for base. And then there's only one function we need to worry about, call diamond with EIP 3009. Let's add that to our contract methods. Now if we come to My Smart Contracts, here we go. There's that function, hit details, contract method ID, copy that. And then let's put that method here. We can hit save. And then at this point, we could actually just turn the workflow on and start relaying for the base network. And if we do the same procedure for Arbitrum, Avalanche, and Linnea, we could relay for those networks as well. But let's go through getting a quote without actually doing a swap first. So on your webhook trigger, this route here, that is your test route. So when I activate this, execute once, it's going to use that test route. So let's grab this example curl command here. Grab that, and then open a VS Code or something. Put that example curl command here, and let's just be sure that that test route is the same as what we're going to be curling. And then let's set up this post body to just work on the base network. So 8453, the from token, that is USDC. Let's just do $1 worth, a quote for $1. And then the from address, make sure that's your address. Okay, so change the from address to your address. And then let's use this to get a quote from our workflow. If we activate it, and then run our curl command, you can see here it went through Li.Fi, got a quote, detected we did not have a X payment header, and then sent us back. Here is our quote right here. You can see the swap fee for $1 is about 0.7 of a cent. The gas cost is going to be 2 cents. So that's why I was saying that max amount required, which sets the floor for what you're willing to relay, matters if you were wanting to make money off of the swap fees for doing this for users. So now let's try to do an actual swap. To do that, on the One-Shot API website, if you click the Tools tab, there is a x402 header generator. If you don't already have a mini app made or some kind of web interface made to interface with your DApp backend, you can use this tool so that you can make curl requests really easily. So let's fill this out. The token address is this asset address. Copy that, paste it here. The to address is here. Let's make it valid for 120 seconds just to give ourselves some extra time. And then we want to do $1 worth. So make sure that the amount that you create the authorization for is the same as the from amount. If they are different, the workflow will throw an error in this error field saying that those two amounts have to match. We're on the base network. Let's create our header. Confirm. Copy that. Put that here in our curl command. Now let's turn back on our workflow and try to perform our swap. There you can see we completed the workflow here, and our API call sent back a transaction hash. So if we grab that transaction hash and open Basescan, we can paste that here. And here's our transaction. If we look at the cost of running this transaction, this was about 3 cents. So we'd want to tune that relayer fee that we are charging at the end of the day so that we come out on top when it comes to relaying transactions through Li.Fi. So I hope you enjoyed watching that. I hope it was informative. It shows you some good patterns on how to build on-chain N8N workflows. Again, I recommend having a code block for configs, and if you are using webhook triggers, validate and verify information in the post body. And if you're doing x402, you can use the code node here for some helpful functions for validating the X payment header. Give this a shot. If you have questions, ask the team in Telegram, and watch out for other videos coming from us again soon.